Okay, so for our next example, we are going to look at ASH3. So if we're asked to generate the Lewis structure for this particular molecule, we know that arsenic is in group 5, so there's one of them. And with hydrogen, we know that there are 3 of them, and each contribute 1 valence electron because they are in group 1. So we know that when we are all done, we should have 8 valence electrons in this molecule. Now, for this particular structure, we know that we have to generate a skeletal structure, and we know that hydrogen is never the central atom. So we know that we have our arsenic as our central atom, and it is surrounded by the hydrogen atoms. So we've done step 2. Step 3 would be to draw single bonds from our central to all of our terminal atoms. So we draw single bonds from the central to all of the hydrogens. Then we have to give our terminal atoms, our hydrogens, an octet. So if we look at this, we see, okay, hydrogen right now has 2 electrons around it. So I need to draw 6 more around each hydrogen, right? Well, you have to remember that hydrogen is an exception to the octet rule, and it only wants 2 valence electrons. So, because there are already 2 in the bond, each of the hydrogens already have an octet, and I do not need to draw any more around them. So, I have my terminal atoms have an octet, and I need to compare how many I've drawn versus how many I should have. So, right now, in my structure, I've drawn 6 valence electrons, and I need to draw at least 8. So remember, when you've given your terminal atoms an octet, any remaining electrons you put on the central atom as a lone pair. So I have 2 left over, and I put them on the central atom as a lone pair. So I've used all of my valence electrons. I've drawn 8. The hydrogens have an octet. I have to look, does my central atom have an octet? And what I see is, yes, it has 8 electrons surrounding it. So this is the Lewis structure for this particular molecule. Now, in terms of a 3D molecule, I look at the central atom and I see that in total there is 4 regions of electron density. And this has it narrowed down. I have it narrowed down to a couple of different shapes. It can either be tetrahedral, trigonal pyramidal, or bent. Now, I have to look at what type of electron density is around the central atom. And I see that I have 3 bonding pairs and 1 lone pair. So I know that that narrows down my shape to trigonal pyramidal. Now, in terms of generating a 3D molecule, you know that when you have 4 regions around the central atom, that you're going to have the overall general structure where we have 2 bonds in plane, 1 coming out, and 1 going behind. So, again, this is in general to any molecule with 4 regions of electron density, regardless of what type of electron density. So, for this molecule, I have arsenic as my central atom. I have 2 bonds in plane. I have 1 coming out of the plane and 1 going behind. Now, because all 4 of these bonds are equivalent, just like what we saw in the previous example, that means it does not matter where I place my lone pair. So I'll put my lone pair here. Had you put it on any of the other 3 bond positions, it would still be correct. So I put my lone pair there. I then input my hydrogen, and I have correctly generated the Lewis structure for this molecule.